Today we're going to take a look at how to solve logarithmic equations. But first, I just want to remind you that if we have an expression like this, e to the ln of x, that simplifies to just be equal to x. So if we had e to the ln of 7, that's equal to 7. Or we can go crazy and have e to the ln of pi, that would just be equal to pi. Now there are two methods that we can use in order to solve log equations. The first one is to take our log equation and to write it in exponential form. So let's say we had log base 2 of x plus 3 equals 5. And you've already solved equations like this when we talked about converting between different forms. We start with the 2. 2 to the 5th power is equal to x plus 3. So let's write that. We've got 2 to the 5th equals x plus 3. And now we just isolate our variable. We've got 2 to the 5th is 32. Subtract 3 from both sides. So x must be equal to 29. Now we can do the same thing if we had an equation with the natural log. So that might look something like this. Let's say we had ln of 3x equals 2. Now we know that the natural log is really log with a base of e. So we convert this to exponential form. We take e squared equals 3x. We isolate x. So x is e squared over 3. Now depending on our directions, we could leave our answer in terms of e, but that's approximately equal to 2.463 if we need a decimal answer. Now our second method is to exponentiate. So let's start off with the same equation. We had ln of 3x equals 2. Now instead of converting that into exponential form, one thing we can do is make each side of this equation a power of e. So we're going to take this and make it a power, and this and make it a power. So that'll look like e to the ln of 3x equals e squared. And that's okay to do because we did this to both sides of the equation. So notice how this expression is this exponent, that expression is that exponent. What we did here was exponentiate. And this is a nice way of solving natural logarithms because e to the ln of 3x is just equal to 3x. That simplifies very nicely. Divide both sides by 3, and we get the same exact answer that we did before. Let's look at one more example like this. Okay, so let's say we had something a little more complicated, like this. We still want to isolate the variable as much as we can, so let's subtract out this 3. We get negative 2 ln of 4x equals 4. We can divide both sides by negative 2. And we have ln of 4x equals negative 2. Now to exponentiate, we are going to make each side of this equation a power of e. So we're going to have e to the ln of 4x equals e to the negative 2. Now on the left side, e to the ln of a quantity is just equal to that quantity. So left side, we get 4x equals e to the negative 2. Isolate the variable. x equals e to the negative 2 over 4. Now that's our answer in terms of e, or this is about 0.034. So you now have two ways of solving log equations. One way is to write the log in exponential form and then solve for the variable. Your second method is to exponentiate, which is really rather convenient when you're working with natural logarithms.